Review of basic concepts. R4. Factoring polynomials. The process of finding polynomials whose product equals a given polynomial is called factoring. Look at this example, 9x squared minus 27. This is a binomial. Think about it. What is the common factor? We do have a 9 here, we do have a 27. So you can know that 9 is going to be the common factor. We could rewrite it 9x squared minus 9 times 3, which is going to be equal to 27. So we could factor out the 9. So you're going to get x squared minus 3. Okay, so you could double check your work, distribute it back. You're going to get the same things here. Write an equivalent expressions by factoring. So we do have the trinomials here. We do have a 3 terms. First, we're going to only look at the numbers. 25, 35, 15. Think about it. What is the common factor? The common factor will be 5. Right? The greatest common factor is going to be 5. Okay, now we're going to look at the variable of x. So what is the greatest common factor? We could take out 2 of them, 2 of them, and 2 of them. So the greatest common factor will be x squared. And also for the y, what is the greatest common factor? That would be y to the power 3, right? Okay, so you know when I multiplied it together, the 5x squared y cubed is the greatest common factor of these 3 terms. So we could write it outside and think about it. 5 times 5, I got a 25 here. So I have a 5 and I take out x squared already. And then I only left with y squared. So the first term will be 5y squared. Second one, 5 times 7 equal to 35. So I have a 7 and then 6 take out 2. So I have a 7x fourth and then take out the y third already. Okay, so do it like one by one. You always can double check your work. Just use the distributive law, multiply it like one by one. You should get back to the original questions here. Polynomials that cannot be factored further are said to be factored completely. The factors in the resulting factorization are said to be prime polynomials. And when the leading coefficient is a negative number, we generally factor out a common factor with a negative coefficient. So if the leading terms, the first one is a negative number, we usually factor out the negative coefficient. Okay, I want you guys try to do this example. So A here, the greatest common factor will be 6a squared. Okay, 6a squared. But keep in mind that when you factor out the 6a squared, you're gonna leave the 1 in here. Okay, so 1 minus 3a squared. B, look at 14, 28, 21. Common factor will be 7. And then I do have x squared, x squared, x cubed. So x squared will be the greatest common factor. And then y squared. So you want to factor out 7x squared, y squared. Okay, last one. You do have a x minus 2, x minus 2, and x minus 2 here. Okay, so you could factor out the x minus 2. Okay, inside here, you want to distribute it one by one. Okay, remember we do have the formula x minus y squared. You could make it like x squared minus 2xy plus y squared. And then we're going to distribute one by one and then combine the 9 terms. Okay, combine the 9 terms. You're going to get this. Okay, right? Factor by grouping. The largest common factor is sometimes a binomial. Often, in order to identify a common binomial factor, we must regroup into two groups of 2 terms each. I need you guys remember this method, factor by grouping. Okay, look at these expressions. So you can see I have a x plus 4 times n. This is considered one term here. Plus, they multiply it together. So this is another term. So x plus 4 times y minus b. So you can see we do have a common factor of x plus 4. So we're going to factor out x plus 4 first. When we take out x plus 4, we're left with m plus y minus b. M plus y minus b here. Okay? This is the idea of factor by grouping. Okay, let's look at the example. Write an equivalent expression by factoring. So you can see we do have 4 terms, 1, 2, 3, 4. Usually, if we want to use factor by grouping, we do have 4 terms in here. So what we're gonna do for this one? First, we're gonna regroup the first 2 terms. Look at these first 2 terms. What is the common factor? And then look at the last 2 terms here. Figure out what is the common factor. Okay, so look at here. The common factor will be y to the power of third. And then the second one here, the common factor will be 3. So okay, let's factor out the y cube here. We're left with y squared plus 5. Okay, the last 2 terms, we factor out the 3. So we have a y squared plus 5 here. Okay, last step, we are not done yet. Okay, so you can see we still have the common factor, y squared plus 5, y squared plus 5. So we're gonna factor out. We're left with y cubed plus 3 here. Okay, this is the idea of factor by grouping. One more time, when you have 4 terms, think about this method. Okay, now I want you guys try to do it by yourself. One more time, group the first 2 terms, group the last 2 terms, factor out. Okay, try. Okay, so here, the first 2 terms here, and then last 2 terms, before I factor out, I could factor out the negative first. Okay, I just factor out the negative. When I distribute back, it's negative 5s minus 15. Now, factor the first 2 terms. Common factor will be r squared, right? And then the last 2 here, the common factor will be 5. And then you're gonna see we do have a common factor, s plus 3. So factor out. And that's it, okay? Okay, B. Do the same thing. Common factor will be m squared here. And this one, n, will be the common factor. and then factor out 4 minus n. So you're left with m squared plus n here. Okay, right? Factoring trinomials of the type x squared plus bx plus c. Okay, previous example, we are working on the polynomial. We do have a 4 terms, and then we're going to use factor by grouping. Right now, we do have a 3 terms. That's a trinomial. And this example, we are working on the coefficient of x squared that has to be equal to positive 1. Okay, this guy has to be positive 1. So remember the FOIL method that we multiplying two binomials? Look at this example. When we have two factors, x plus 2 times x plus 5, when we multiply it, we'll be using the FOIL method. So x times x, you're going to get x squared. X times 5, you're going to get 5x. 2 times x, you're going to get the 2x. And then at last, 2 times 5, you're going to get the 10. Okay? And then we're going to combine the 9 terms. So this is what I get. My trinomial will be x squared plus 7x plus 10. Now, we want to do the factoring trinomials. Means I'm going to give you guys these trinomials and you're going to use your method to factor out to get x plus 2 times x plus 5. So, let me write it like this way. X squared plus 7x plus 10, this is my questions. Since the a has to be positive 1 here, so the only way we could get the x squared would be x times x here, right? So we need to figure out what is x plus p times x plus q. If we were using the FOIL method to distribute it one by one, we're going to get this guy. So we're going to know, we need to figure out when p times q, it has to be equal to 10. And then when q plus p, it has to be equal to 7. Okay, so we need to know how to find these two numbers. We do have a different way to factor out the trinomial, and I will be using the x method. You don't have to use my x method. You could use your own way. As long as you show me your work, you get the correct answer, you get the credit on the exam. Okay, let me show you guys what is my x method. So first, make sure this is going to be positive 1. And then I put the x here. On the top, I put the multiplication. On the bottom here, this is going to be the addition. Okay, we're just saying that we need to find two numbers. P times Q equal to 21. So I put the 21 on the top. And then we need to find two numbers. P plus Q has to be equal to 10. Okay, so think about it. I need to find two numbers. When they multiply it, it's going to be equal to 21. When they add it up, that's going to be equal to 10. So you could think about like 3 times 7, right? When you multiply it, 3 times 7 equal to 21. 3 plus 7, that is going to be equal to 10. Okay, so your factor will be x plus 3 times x plus 7. This is called the x method. I want you guys try it for the part B here. Okay, first, multiply. So you could get negative 20. Okay, make sure including the sign here. Negative 20 on the top. Here, that's going to be negative 1 on the bottom. So you need to find two numbers. When they multiply it, it's going to be equal to negative 20. And then when they add it up, it's going to be equal to negative 1. So think about it. You could think about like 5 times 4, right? Since when they add it up, it's going to be negative 1. So that will be negative 5 times 4. Okay, multiply it equal to negative 20. Add it up, that's going to be equal to negative 1. So my factor will be x minus 5 times x plus 4. Okay, how about when your a is not equal to positive 1, what you gonna do? Okay, let me show it to you guys. I'm still using the x method. There's a little bit difference here. When you put the multiply, you need to do 5 times negative 12, which is gonna be equal to negative 60. Okay, one more time. 5 times negative 12. And then for the addition, I just put like 4 here. So same idea, I need to find two numbers. When they multiply it, equal to negative 60. When they add it up, that's gonna be equal to 4. Okay, if you don't have any idea, you could write it all out. Okay, 60, you could be 1 times 60, or 2 times 30, or 3 times 20, 4 times 15, and 5 times 12, or 6 times 10. That's it, right? You could see the number is going to be in order, like this way. Okay, right? So think about it. All this number, when they multiply it, it's going to be equal to 60. But when they add it up, it's going to be equal to 4. So when it's a negative 60, so either one of them is going to be negative. So you could think about it, finding the difference. Which one, when you add it up, is going to be 4? It will be this guy, right? If the 6 is a negative 6, this is going to be 10. Okay, we are not done yet because the a here, this is not the positive one. So what I'm gonna do, I'm gonna divide by 5x. Okay, 5x, that's from this guy, divided by 5x. When you look at it, now this guy, I could simplify it. So that will be 2 over x, right? Divided by 5, divided by 5. Okay, what is my final answer? You're gonna look at like this way. This means 5x minus 6. And this is gonna be x plus 2. So that will be your final answer. Okay? You could double check your answer. During the exam, once you're done, just use the FOIL method, distribute it one by one to see if you got back this guy. Okay, last one. I want you guys to do it by yourself. Okay, on the top, multiply. So you're gonna do 12 times negative 3. And then here, you're gonna put negative 5 here. So find two numbers. When you multiply it, you're gonna get negative 36. When they add it up, that will be equal to negative 5. So one more time, if you can't figure it out, try to write it out. Starting from 1, okay? 1 times 36, and then 2 times 18. 3 times 12. 4 times 9. And cannot be 5. And then 6 times 6. Okay, right? Then find the difference. One will be equal to negative 5. It will be this guy, right? So I can have 4 times negative 9. And then divided by 12x. Simplify it. So your final answer, 4x minus 3. And this is going to be 3x plus 1. Okay, last one. So before you work on this trinomial, first thing you need to do is, do they have a common factor? What is the GCF? Greatest common factor here. You could factor out the 3, right? Factor out the 3. Now, this guy, you can use the x method. So that would be x times 5. You're going to get 40. And then 14, that will be here. So find two numbers. When they multiply it, that will be equal to 40. Added up, that was equal to 14. So write it out. 1 times 40, 2 times 20, 4 times 10, 5 times 8. That's it, right? Okay, which one added up is going to be equal to 14? That will be this guy, right? So 4 and 10 here. And make sure you're going to divide it by x. Simplify it. So your final answer, that will be 2x plus 1 times 4x plus 5. Okay, you do have a 3 here. Keep your 3. Okay, perfect square trinomials. Consider the trinomial x squared plus 8x plus 16. For this kind of the questions, you can use the x method. Okay, that's the same thing. But actually, if you factor out, you're gonna get x plus 4 squared. And we say this is the perfect square trinomial. If you could recognize this is a perfect square trinomial, it will be a lot easier, okay, without using the x method. Before that, I need you guys to remember these two formulas. A plus b squared is equal to a squared plus 2ab plus b squared. Another formula will be a minus b squared equal to a squared minus 2ab plus b squared. So when you guys look at the trinomial, if you could write it like this way, then that's a perfect square trinomial. Okay, first, look at it. Do we have any GCF? No, right? So I want to use this formula. Let's try to write out this formula here. Okay, I have a squared plus 2 times ab plus b squared. So first, figure out what is my a squared here. This is a 49x squared. So I'm supposed to have a 7x squared. Okay, 7x times 7x, which is going to be 49x squared. This guy, 4y squared, it can be 2y, right? 2y times 2y, which is going to be 4y squared. And then for my formula, 2 times a and b, 2 times a and b. So I plug in 7x and then 2y here. Now double check. 2 times 2 is 4. 4 times 7, which is going to be 28. 28xy. It matches with this guy. So I can apply this formula. So that will be, your a will be 7x, your b will be 2y. So 7x plus 2y squared. Get the idea, right? Okay, this one, trying to do the same thing. This is a subtraction, so we're going to be using minus here. So now you're going to figure out what is your a here. Okay, what multiplied by itself, that will be equal to 81a squared b squared. The last term here, what square is going to be equal to 25? Then you're going to put a and b here. So multiply it, make sure that's equal to 90ab. So first one, that will be 9ab squared, right? 9ab times 9ab, which is going to be 81a squared b squared. Last one, 5 squared, that's equal to 25. And then we're going to plug in a and b here. Double check. 5 times 2, that is equal to 10. 10 times 9, 90. 90ab. Okay, so plug in this formula. 9ab minus 5 squared. I highly recommend you guys memorize these two formula, okay? Because sometimes if you want to distribute this guy, you don't have to use the FOIL method. You could just memorize by the formula. And also that will be a lot easier for factoring perfect square trinomials if you remember the formula. Okay, another formula you guys need to remember. This is called factoring a difference of two squares. A squared minus b squared equal to a plus b times a minus b. When you have binomial, only two terms, and you want to do the factoring, think about this formula. So I could use this formula because I have a two terms, and 49, I can revise it to b squared, right? So by the formula, x squared minus 7 squared, that will be equal to x plus 7 times x minus 7. Every time when you have a two terms and with the square, you're gonna try to use this formula. A squared minus b squared equal to a plus b times a minus b. Okay, try. Plug it in. Y squared equal to 64x squared. Y squared equal to 49. You should get xx and 7, right? So by the formula will be xx minus 7, xx plus 7. Okay, this one. We don't have the square here, but think about it. Do they have GCF here? I could factor out the x fourth here, right? X fourth. So take out x4, I only have x squared here. Take out the x4, there's nothing here. Now I do have x squared, just like the previous example. So think about it, what you're gonna put here. That will be 13x. And then y squared is equal to 144, 12. Okay. So I have a 13x minus 12 times 13x plus 12. Okay, this one looks complicated, okay? Don't distribute it. First step, I will let x equal to 2c minus 3d. Plug it in. Okay, we do have a square and square here, so we could use the formula. So this guy, I divided, that would be 4f times 4f, which is going to be 16f squared. Okay, 1 minus and 1 plus. Once you're done, you're going to put it back x equal to 2c minus 3d here. And that's it. Okay, one more time. When you have a binomial means two terms. With the square, you want to use this formula. Okay, factoring is pretty important, and I will attach these notes for you guys on Canvas. So this is the factor strategies. First step, you're gonna factor the GCF if necessary, and this is just the example. Okay, after that, you're gonna determine how many terms do you have. If this is a 4 terms polynomials, you will be using factor by grouping. Okay, factor first two group, factor the last two group, and then find out the common factor. If you have a 3 terms, that's a trinomial. So the format will be ax squared plus bx plus c. If a is equal to positive 1, okay, that will be like this, using the x method. Okay, this is pretty straightforward. If a is not equal to 1, then you'll be using here, this example, a times c for here. B will be here. Okay, this is the way how you take care of trinomials. If you have a 2 terms binomials, we only cover like the square. Okay, this is the example. We'll be using the formula. Okay, if you have a binomial with the cubes, they'll be using this formula. We didn't cover it for this session, okay? But this is a really good notes for the factor strategies, okay? I will put it on Canvas. You could print it out by yourself. That's it for the R4.